Hi everybody, I hope this video finds you well. In today's video, we're going to be starting into talking about actually how to do some descriptive statistics, starting with descriptive statistics for categorical variables. So far in our class, we've been mostly focused on how to collect data and also how to sort of build a shared or common language for talking about statistics. Now it's time to actually talk a little bit about what we can do in statistics. And the first part of that is learning how to sort of summarize, organize, visualize data. To start off with, we're going to put our attention on categorical variables. So, for our class, when working with categorical data, we're going to focus on a very particular type of categorical variable, specifically one where each individual is placed into a single category. For these types of variables, we're going to be interested in the following sort of summaries and visual displays. Before we talk about these ways of summarizing and visualizing categorical data, the reason we're going to be interested in these ones where people are placed into a single category is because in these situations, that means that the sort of number of responses that you get directly matches the number of individuals in your sample, right? If you allow people to put themselves into multiple categories at a time, it actually makes the analysis part a little bit more complicated. We will talk briefly about variables like that in the next video that relates to categorical variables, but that's not really our point of emphasis in this class. Instead, we're going to almost always work with categorical variables where when an individual is placing themselves, they get to only place themselves in a single category. So let's talk about some ways of summarizing and organizing this data as well as visualizing it. So in our class, we're going to learn two ways of summarizing or organizing categorical data. We're going to learn what's called a frequency table, which is sometimes referenced as an actual frequency table. If you don't see that word actual attached to it, you can just assume that it's there. So a frequency table and an actual frequency table are the same thing. What a frequency table is it shows each category of the categorical variable. So it gives you a list of what categories you allowed people to choose from or what categories you put individuals into, along with the corresponding number of individuals that landed in that category. So if you think about that, a frequency table is sort of the most basic way to organize categorical data. It tells you what were the categories and how many individuals landed in each category. The second way that we're going to talk about sort of organizing or summarizing categorical data is what's called a relative frequency table. Relative frequency tables show, again, each category of a categorical variable along with the corresponding relative frequency. What is a relative frequency? Well, it's basically saying what was the relative frequency of the overall sample that landed in that category. Usually when we go to write relative frequencies, we write them as a percentage. So instead of saying that maybe 17 people landed into a category, well, that 17 doesn't necessarily mean a lot unless we know how many people there were. If that's 17 out of 17, that's 100%. That's everyone. If it's 17 out of 100, then it's only 17%. So a relative frequency table sort of gives us a better sense of how many people or individuals landed in a particular category relative to how many people we overall sampled. All right. Why do we often use relative frequency tables as opposed to frequency tables, or why do we even need to sort of bother discussing this second sort of way of organizing? Well, it turns out, of course, that most people have a much harder sort of time working with really sort of large numbers. Most of us are pretty comfortable sort of understanding, how big, say, like 15 is compared to 30 or something like that, but then it gets a lot more complicated when the numbers are a lot larger. A lot of us have a hard time really understanding how big of a difference is there between, say, 178 and 249? Is that twice as big? Is it 50% larger? Having percentages really helps with people's number sense and gives them a much better, sort of clearer picture of the data. All right, so those are going to be our two main ways of summarizing categorical data. In just a moment, we'll actually take a look at some data and learn how to build each of these tables. But before we do that, we'd also like to talk about some ways of visualizing categorical data. At the beginning of our class, we're going to learn quite a few different visual displays for different types of data. And of course, it's an important aspect because if you're trying to convince somebody or you're trying to sort of really demonstrate something to someone, one of the most convincing things you can do is have a nice, clear, and easy to follow visualization. So let's talk about some ways you can visualize categorical data. So the first thing that we'll talk about is what's called a bar graph. A bar graph basically displays each category on its horizontal axis and the frequency, or relative frequency, on the vertical axis. Notice that this means that when you build a bar graph, you can sometimes build what is called like a frequency bar graph or a relative frequency bar graph. You can use either one as your vertical axis. Each bar is drawn to a height that corresponds to its frequency or relative frequency. Bar graphs basically are there to help viewers visualize the frequency of one category against another. If one bar is much, much taller than another one, then you know that that category was much more frequently chosen than the other. So it's very good for comparisons of one category against another. Couple quick notes that we'll see when we start to actually construct these bar graphs in a moment. Bars in a bar graph do not touch. This is really, really important because later on we'll talk about another visual display that is for quantitative data called a histogram. Histograms are very similar to bar graphs, but in a histogram the bars touch. So to a viewer, when you see that the bars do not touch, you know that the data that's being discussed is categorical. If the bars do touch, then you know it's actually a histogram and the data that's being sort of visualized is quantitative. So it's absolutely essential that when you draw a bar graph, the bars do not touch. The second note that I want to make here is that the vertical axis of a bar graph, some people would say that the bar graph is a vertical display of information. All the information you're getting visually comes from the verticality of the diagram. So the vertical axis of a bar graph must start at 0. So you have to start it from 0 and have a consistent scale up. And we'll see that in a moment when we actually get to our example. The second main way that we're going to learn to visualize categorical data is probably one of the more famous ones, a pie chart. A pie chart displays each category as a slice of a circle that corresponds to its relative frequency. Pie charts are there to help viewers visualize the frequency of each category relative to the whole sample. So pie charts aren't really that great for comparing one category against another, but pie charts are really, really useful for helping people understand how much of the overall sample was made up by a single category. One thing you should note is that pie charts are always based on the relative frequencies because you need to know the relative frequency to know how much of the circle you should slice off for each category. Alright, so overall for categorical variables, things are pretty straightforward. We have two ways of summarizing them, frequency tables and relative frequency tables, and two ways of visualizing them, bar graphs and pie charts. Let's go ahead and get right into an example where we take a look at building these different summaries and displays, as well as getting these different visualizations. So, for our example here, let's suppose that we have a researcher that wants to study the favorite film genre of students at a local college. So to do this, the researcher randomly selects 60 students from this college and sends them a survey that asks, what is your favorite genre of film to watch? They get to choose between action, comedy, drama, romance, horror, and other. The researcher gets the following responses. So you see somebody said action, then drama, then another drama, comedy, action, comedy, horror, romance, other, so on and so forth. So this is just a pile of raw data here. And you'll see that's why we want to try to summarize and work with this and organize it in some fashion, because when you just look at this, it just looks like a big block of words, because that's all it really is. So what are we going to do with this? Well, to start off with, we're going to do a couple things as review. We're going to identify the population sample and individual, just like we were doing earlier. And we're also going to identify the sampling technique that the researcher used here to actually build the sample. Then we're going to construct the two organizational techniques we talked about, the frequency table and the relative frequency table. And then we're going to talk about the two visual displays for this data, a bar graph using the actual frequencies and a pie chart for the data as well. So let's go ahead and get started with this. So first of all, let's talk about the population, sample, and individual. So we'll do that right here. So we want to be able to sort of diagnose the population, sample, and individual. All right. Well, we might look through this and immediately sort of think, well, he selected 60 students, so our sample might be those 60 students. But we have to be careful here. This doesn't necessarily look like we got 60 responses. So let's go ahead and just quickly count this. We can see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. So we only had 34 of the students respond. That's going to be our sample. So our sample is 34 students. And if you wanted to make a note, that means n equals 34 here. Well, once we have the sample, it's very easy to get the individual, one student. And the population, well, they did say that they wanted to study the students at this local college. So the population would be all students at this college. So they wanted to study all the students at this college. What they ended up studying were 34 students from this college. And of course, the building block of both of those, population and sample, is one single student. If at this point this should seem very familiar because we've had this sort of structure over and over again, one thing I just want to call attention to, we may have mentioned this in some of the previous videos, but do keep in mind that whenever you're writing population, sample, and individual, notice that the variable is nowhere to be seen. We don't have any mention of favorite film genre. Why is that? Well, because in a more sort of realistic statistical survey, you might collect dozens or even hundreds of variables about every person. You might ask them 30 questions or 50 questions or something like that. So the variable never shows up in your description of the population, sample, or individual. Notice there's no mention of what we were studying about these people, just who they were. Well, we know that who they were 34 students from the college, trying to represent all the students at the college, built out of one student at a time. All right, let's talk about the sampling technique here. Well, if we go back up here, we do notice that they mentioned that the researcher randomly selected 60 students. We get no other information. It doesn't say how they did this process. So all we know is that they did it randomly. That means that the sampling technique that was used here was an SRS. It's a simple random sample. It can't be anything else because we don't have any other information. We know it's done randomly, so we know it's not a convenience sample. We know that there was no system described, so it's not systematic. And there was no prior classification, so it's not stratified. And they didn't pick them in groups or anything like that, so it's not cluster. So it has to just simply be an SRS. All right, we're going to give ourselves a sort of fresh page. We'll actually keep the data, and then we'll talk about how to organize this into a frequency table and relative frequency table. So we'll go ahead and just sort of repeat this here, and so we have our data here. Let's go ahead and build this into a frequency table. All right. So for a frequency table, first thing we want to do is we want to actually sort of have our category. So this would be our favorite film genre. Notice that by forcing the respondents to choose a favorite film genre, you're having everybody only give one response, which is why it's a type of variable that we're going to be studying in this class. Things would be more complicated if you ask the question, which of these genres do you watch? Because then one person might answer action, comedy, romance, horror, and other. They'd give 5 different responses. But by having them choose their favorite genre, every individual had to give a single response, and that makes the analysis a lot simpler here. So we have favorite film genre, and we want to have their frequencies. So we can just put them in the order that they were listed. So I think we listed them as action, comedy, drama, romance, horror, and other. Okay, so it doesn't matter the ordering that we have for them. We'll just give some lines here so we can sort of read this more easily. Okay, so let's build our frequency table. So what we want to do is we want to say how many individuals fell into each of these categories. So it's just going to be a little bit of counting. If we go through here and count up the action, it looks like we have 1, 2, 3, 4, 5, 6, 7, 8. So it looks like 8 of the individuals that we sampled chose action. So we can put the frequency as 8. For comedy, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for comedy. So we had 11 people choose that. For drama, looks like we had 1, 2, 3, 4, and that's it. So only 4 people chose drama. For romance, we had 1, and then looks like 2, and that's it. So 2 for romance. Horror, well, we had 1, 2, 3. So it looks like 3 for horror. And then for other, we can go through and do our final sort of count there. It looks like we've got 1, 2, 3, 4, 5, and 6. So we got 6 there. All right, so there we go. That's what a frequency table looks like. You have the different categories and you have their frequencies. One thing we might want to add to a frequency table that's usually good practice to have is a total. So let's go ahead and do that as well. If we total up these frequencies, 8, 19, 23, 25, 28, 34. So our frequency is 34. What do we notice about this 34 here? Well, of course, the total in this situation, this is also our sample size that we noticed on our in the beginning here. If we go back over here, notice we noted that there were 34 students who responded, so our n was 34. It should not be a surprise that the sum of all the frequencies is equivalent to the sample size. Again, that hinges on the fact that we had everybody choose their favorite genre, so they were only able to give one response. If they were able to choose as many genres as they liked, there's no guarantee that it would sum up to the sample size there. But if you have everybody give just one response, then the sum of all the frequencies has to be equivalent to the sample size. Okay, before we get on to discussing the relative frequency table, I would like to just make a general comment here about this sort of question. One thing I want you guys to sort of be aware of is that right now we're just sort of summarizing, and in a moment we'll do some visualization of this data. But you could already think about how you could sort of analyze whether or not there might be some issues with how this researcher phrased this question. One thing that you should sort of keep in mind is that if their goal was to understand the favorite genre of film to watch, and they're saying, you have to pick from these, maybe people aren't really sure, right? Some of these genres might sort of bleed over into one another, right? There's a lot of movies that I think people would consider action and drama, or a lot of movies that people might consider comedy and romance, right? And if somebody's picking their favorite genre, they might be choosing comedy, but what they're really thinking about is romantic comedies. Or somebody who's choosing action actually specifically means they like watching war movies or something along those lines. So one thing that's sort of here is that by having these really big, broad categories, you might have people sort of lumped into the same category, even if they don't necessarily share the same genre of film. They just happen to be in the same sort of big, overarching genre of film. That's especially true with something like the other category. Somebody who's in that other category, somebody who picked that, they might have picked documentaries. That might be their favorite genre of film to watch. Somebody else might really like animated films or musicals or something like that. Now, those people all get lumped into the same category, but they don't necessarily share any similar tastes. That's a big danger of using a category like other. Now, of course, if we didn't include that, and we just said you had to pick between these, well, that's also dangerous, because then people who might not like any of those genres have to sort of force themselves either to not respond or pick a genre that isn't really their favorite. You might say then, well, wouldn't it be better to just list a bunch of things like action, comedy, drama, romance, horror, documentary, musical, animated, children's, so on and so forth, right? Reality, war movies, biopics, mysteries, and just list out as many genres as you can think of. Well, then everybody could be very specific, but then think about what's going to happen. If we only had 34 people, we might only get 1 or 2 people in every category, which doesn't really give us any information. My whole point of this is just in terms of realistic statistics and really think about using it in the real world. When working with categorical variables, it's very easy to just come up with categories, but it's a delicate balancing act to do it really well. You want to have big categories so that you can sort of actually get good patterns and a good amount of data in each category, but you also want some precision to make sure that people that land in each category actually share some similar traits. And trying to balance that out is actually part of the sort of art of designing a good survey question that's categorical in nature. Is that a little beyond the scope of our class? For sure, but I just like to sort of mention it to you guys so that you're aware of it. For now, though, let's go ahead and construct the relative frequency table from this data. So what we're going to try to do is we're going to build this right here. So for the relative frequency table, it's still going to have your same category, so favorite film genre, and we'll write them in exactly the same order. So action, comedy, drama, romance, horror, other. and we'll put the relative frequency, which often we write as a percentage. So how do we convert these things into percentages? Well, we want to know how much they represent relative to the whole sample, which is 34. So to do this, what we're going to go ahead and do is we're going to divide. We're going to convert by dividing by that n, that sample size. So we're going to take every one of these values and divide by 34. So let's go ahead and do that. So if you have a calculator, you can follow along with that, right? 8 divided by 34, you should get a decimal like 0.23529, so on and so forth. We're going to convert that to a percentage. So we're going to shift the decimal place 2 places to the right. We're going to round so that we have 3 decimal places before we convert to a percentage. So what that means is if you're looking at your calculator, you should get that that is 23.5%. So in other words, slightly under a quarter of all the people in our sample, 23.5%, chose action as their favorite film genre. All right. For comedy, we do the same thing, 11 divided by 34, and we should get, after rounding, 32.4%. So a little under a third of all the people chose comedy. For drama, it's 4 divided by 34, so we should get 11.8%. For romance, 2 divided by 34, we should get 5.9%. For horror, 3 divided by 34, so that's 8.8%. And for other, it's 6 divided by 34, so 17.6%. And we'll put some lines so that we can read that a little bit better. There we go. Now, if we total those up, what should the total be here for a relative frequency table? Well, if you add all those up, except for maybe a little bit of rounding, this should come out as, of course, 100%. It might, depending on the rounding, come out as like 99.9% or 100.1%, but overall, these relative frequencies should sum up to very, very close to 100%, because we're saying what percentage or what part of the whole sample each of these categories represented. All right, so in this case, we saw that it was very easy to go from the frequency table to the relative frequency table. Could we go the opposite direction? Well, obviously in this case, if we wanted to go from here to here, we could just grab this. But what if we started with this? Would it be possible to get the frequency table? Well, if you think about it, it would be reversing this. So if we use division by n to build the relative frequency table, if you ever need to, you can use multiplication by n to go backwards. So if you want, you can multiply by n. So you would still need to know the sample size. If you take each of these percentages, multiply by n, you will get back to each of these frequencies. So in other words, what I'm really trying to get you guys to sort of see here is that if you know one of these two, you can get the other one. If you know the frequency table, you can divide by n to get the relative frequency table. If you know the relative frequency table, you can multiply by n to get the frequency table. All right. Let's change gears from simply organizing this to actually constructing some visualizations for this. So we'll go ahead and we'll give ourselves a blank page to do this. Now, if we go back and look at what we want to do, we want to construct a bar graph using the actual frequencies. So just to make that a little bit easier so we don't have to rewrite too much, I'm going to just grab this stuff here, copy that for us, so that we can have that as we sort of look at it. Okay, so let's go ahead, and I guess this would be part E now. So we want to do a bar graph, and we were told to use the actual frequencies. All right, so how do you start with drawing a bar graph? Well, you're going to give yourselves a quarter of a coordinate axis, so we just need that there. This is going to be based on whatever we decide for the frequency, so in this case it's the actual frequencies. So we can label that actual frequency. We need to start it at 0, and we need to have sort of these values on there. So a good scale here could be, certainly you could go by 1, so 0, 1, 2, 3, 4, 5, 6, so on. But you could also go by something like 2s, as long as it's a consistent scale. So there's 0, 2, 4, 6, 8, 10, and 12. Notice that that'll be sufficient because my largest frequency was 11. Down here, you want to go ahead and put your sort of genres. So I'll go ahead and just abbreviate. So we'll have our action, comedy, drama, romance, horror, and other. And it's a good idea to sort of label this as well. So this was favorite film genre. And then we're going to draw bars to each of these appropriate heights. So for action, the frequency was 8. So we'll go ahead and we'll draw ourselves a bar to 8. There we go. Then for comedy, it would be 11. Now again, we're doing this, as I say that, right? We're doing this by hand, so it doesn't have to be perfect, but there are a couple things to keep in mind. One, notice that the bars don't touch. That's very important because that tells the viewer they are looking at something that is categorical in nature, not quantitative. So it's absolutely essential that the bars do not touch. Also, it is good visual practice. Again, you're doing it by hand, so if it's rough, that's okay. Notice my lines are not perfectly straight or anything, but make sure that your bars are each about the same width. Right? The reason is if we made one much wider than the others, say when we were doing romance, we decided to draw romance like that instead. Well, what's going to happen is that a viewer is going to pick up on the larger width and sort of associate that category as maybe being larger than it really is. By keeping all the bars equal width, or at least as close as we can by hand, then people can really focus on the heights, which is what's telling us the information. Also, let's go ahead and finish this up. For drama, we had 4 there. For romance, we had 2, so there. For horror, we had 3, so right there. And then for other, we had 6, so right there. If you want another nice feature, especially if you're a little worried that your bars are not perfect in anything, you can also go ahead and just put the frequency inside of each. So this was 8, 11, 4, 2, 3, 6. And there we go. We've constructed a bar graph using the actual frequencies. Do you always have to use the actual frequencies for a bar graph? Certainly not. You could certainly change this relative frequency in terms of percentages. So you could do something like 0%, 10%, 20%, 30%, 40%, and then go back and use these things to choose the appropriate heights. It's the same visualization. One just uses frequency, one uses relative frequency. You just want to make sure you read what the question's asking you to do and use the appropriate one. Since this one said using actual frequencies, that's what we chose to do. So why do we build bar graphs? Why is it useful? Well, because visually it really tells us things. Right? And it tells us when you see that this bar here is literally half the height as this, that means that this category was half as popular. It really also gives you a weight. Like if you say 11 people picked comedy and 2 picked romance, 11 and 2 are both pretty small numbers. I mean, it might not sound like that's big of a difference. But when you see 11 drawn next to 2, you really get a sense of how much more popular the comedy category was compared to the romance category. So it really helps a person visualize the differences between each of these categories. All right, let's go and try the other visualization, which is a pie chart. So pie charts are always based on the relative frequency table. So we'll go ahead real quick and I'll just grab this so that we can use this here. Okay. Go. Put that back. We didn't want to do that. Okay, there we go. Let's pop this right here. All right, we'll zoom in a little bit. There we go. Okay. So for now, part F, we want to try to build a pie chart. Now, pie charts are, again, something that should probably be done using like a form of technology like a computer or something. Well, we're going to be drawing these by hand, so we're again going to just try to do our sort of best here. So what we'll do, first of all, is we'll give ourselves a nice sort of circle. We'll sort of give ourselves the center of the circle. And then what I would try to do is I would try to pick pieces of this that seem the sort of easiest to draw. So I might start with the action category. 23.5% is just a little less than a quarter. Drawing a quarter of a circle is very easy. So there we go. A quarter would be if we went directly across like that. That would give us a quarter. So we'll just angle it just a tiny bit up. And there we go, right? It's a little less than a quarter, and you can label that piece as action. So there we go. All right, what else would be pretty easy to do? Well, most of us might be pretty comfortable with something like a third of a circle, and the comedy is just a little less than a third. A lot of times when you need to draw like a third of a circle, you can sort of draw that sort of Y shape and sort of get those 3 pieces there. So we can take, if we do that, We can use one of these as that 32.4 and then just make it a little smaller. So it looks like we should maybe do something just like about there or so. So let's go ahead and do that. There we go. We'll call that comedy. All right. Now we'll just have to make some rough estimates. If this is about 50% and this is about that 32, then this should be about 18 that remains, which is about that other. So I guess we could just call that the sort of other piece there. That seems roughly accurate. And if we actually add these, we can sort of see that comedy plus other, 32.4 plus 17.6, actually does give us 50%. So that's a pretty good job there. All right, and now we know we just need to take these and divide this section up. So we would want something that is about 11 or 12%, which should be about half of this size here. So something like about that. So maybe right about there. We can call that the drama section. Again, we're just trying to do our best sort of job on this. It doesn't have to be perfect. And then the horror should be just a little bit above the romance. So cutting it in half would look like something like that. So we'll favor one side a bit. So I guess we'll do something just about like there. We'll call that horror, and we will call that small one romance there. And there we go. Okay, again, doesn't have to be perfect. You're just trying to do your sort of best job. If we were doing this for real, if you were going to do this for a presentation, of course you would use a computer to make sure that everything is drawn perfectly. But why do we want to talk about pie charts? Well, the real thing is for things like this here, right? When you tell somebody that 32.4% of people chose comedy, a lot of people's natural reactions, especially people who sort of are used to like grades and things like that, think 32.4%, and they think about that as a really low percentage. They think 32.4%, that's way below 50%. That's not a lot. But remember, we had 6 different categories. So for one category to get nearly a third of the sort of individuals, or a third of the votes in a way, is a big deal. And you can see visually that when you draw 33 or 32.4% of something, it's a big chunk of the circle. And it really helps people understand, oh wow, one category getting close to a third of the sort of selections, even though there are 6 different categories out there, it really is a big chunk overall. And it really helps people visualize that category relative to the whole sample. So there we go. In this one example, we've done everything that we really need to know how to do with categorical variables. We went back, we took a giant pile of raw data, converted it into a frequency table, took that frequency table, turned it into a relative frequency table, talked a little bit about how you could reverse that process through multiplication, and then went ahead and looked at 2 visualizations. A bar graph that's useful for comparing one category against another, and a pie chart that's useful for comparing each category against the overall sample. In our next video, we'll continue to do a few more practice examples working with categorical variables, and talk just a little bit about that special situation of a categorical variable where individuals can give more than one response.